Have you ever gazed up at the night sky and wondered how it all began? How did the universe come into existence? Humans have pondered these questions for millennia, our curious minds seeking to unravel the mysteries of the cosmos. Throughout history, we've crafted countless theories, each reflecting our ever-evolving understanding of this vast expanse we call home. From ancient civilizations attributing the universe's origins to cosmic eggs or divine beings, to the more recent theories of steady-state and oscillating universe, we have come a long way. However, the theory that has managed to withstand the test of time and rigorous scientific inquiry is the Big Bang theory. This theory posits that the universe began from a singularity, an extremely hot and dense point, and has been expanding ever since. The Big Bang theory is not just a popular television show, but a scientific theory that explains how our universe began. Imagine everything that exists, all the stars, galaxies, and planets compressed into an incredibly small, hot, and dense point. This is the starting point of the Big Bang theory, a compelling narrative that attempts to explain the birth of our universe. Now picture this infinitesimal point known as singularity. It's so hot and so dense that the laws of physics as we know them just don't apply. Then something extraordinary happens. There's an explosion, a bang if you will, and this singularity starts to expand at a mind-boggling pace. As it expands, it also begins to cool. This cooling allows for the formation of subatomic particles, the building blocks of matter. These particles then come together to form simple atoms, mostly hydrogen and helium. This process, known as nucleosynthesis, is a crucial step in the evolution of our universe, but the expansion doesn't stop there. It continues, and these simple atoms start to come together, pulled by the force of gravity. They coalesce into clouds of gas, and under the right conditions, these clouds collapse under their own weight, leading to the formation of stars. These stars don't exist in isolation, though. They group together to form galaxies, vast collections of stars, gas, and dust, bound together by gravity. These galaxies then group together to form clusters, and these clusters form superclusters, creating the large-scale structure of the universe we see today. And it all started from that incredibly small, hot, and dense point, that singularity. This is the essence of the Big Bang theory. It's a tale of expansion and cooling, of particles and atoms, of stars and galaxies. It's a story of how everything we see around us today, from the smallest particle to the largest galaxy, came into existence. And just like that, from a tiny point of extreme heat and density, our universe was born. But how do we know this theory holds water? What evidence do we have? Well, let's delve into the main pieces of evidence for the Big Bang theory: the redshift of galaxies, the cosmic microwave background radiation, and the abundance of light elements. First up, we have the redshift of galaxies. When we look out into the universe, we notice that galaxies are moving away from us. How do we know this? Well, it's a little like the Doppler effect, the phenomenon that causes the pitch of an ambulance siren to change as it zips past you. Light from galaxies does something similar. As a galaxy moves away from us, its light shifts towards the red end of the spectrum, hence the term redshift. This redshift is observed in all directions, indicating that the universe is expanding uniformly. Next, we have the cosmic microwave background radiation, also known as the CMB. This is essentially the afterglow of the Big Bang, still detectable today. It's a kind of radiation that fills the entire universe. No matter where we look, we see this faint glow of heat left over from the initial explosion. It's like the embers remaining from a fire, still warm long after the flames have died down. Finally, the Big Bang theory predicts the abundance of light elements in the universe, such as hydrogen and helium. When the universe was young and hot, conditions were just right for these light elements to form. As the universe expanded and cooled, these elements became less common, but not before a significant amount had already formed. Observations show that the proportions of these elements in the universe match the predictions of the Big Bang theory remarkably well. So there we have it: the redshift of galaxies, the cosmic microwave background radiation, and the abundance of light elements. These pieces of evidence strongly support the Big Bang theory, but the question remains, what caused the initial expansion? The Big Bang theory, while widely accepted, leaves some questions unanswered. It's like a puzzle with a few pieces missing. One of the biggest conundrums is what caused the initial expansion, the spark that set it all off. Was it just a random event, or was there some trigger? And what existed before the Big Bang? Was there a before at all? The Big Bang theory doesn't provide a clear answer to these questions. In fact, under the conventional model, the concept of before the Big Bang is somewhat meaningless, as time itself began with the Big Bang. This is a bit like asking what's north of the North Pole. It's a question that, within our current understanding, doesn't really have a sensible answer. In the face of such mysteries, scientists aren't just shrugging their shoulders and moving on. Instead, they're diving deeper into these enigmas, exploring new theories and possibilities. They're going beyond the Big Bang, so to speak. One such idea is the concept of multiverses. This is the theory that our universe is just one of many, possibly an infinite number, each with its own laws of physics. Some even suggest that the Big Bang was not the beginning, but rather a transition from a previous universe. Another area of active research is quantum gravity. This is a theoretical framework that attempts to reconcile quantum mechanics, the physics of the very small, with general relativity, the physics of the very large. Some believe that a quantum theory of gravity could provide insights into what happened at the very beginning of our universe. The Big Bang theory has taken us far, but there is still much to learn. The mysteries of our universe are vast and complex, but with every new discovery, we get one step closer to understanding our cosmic origins. As we continue to explore the cosmos, we inch ever closer to uncovering the secrets of our universe's origins. The Big Bang theory is our best understanding so far, but who knows what discoveries await us in the vast expanse of space.